Hello everyone. In this video, I will demonstrate how to solve quantity discount models in inventory management. So this is chapter number 10, inventory management, problem number 22 on page number 454. This is for Keith Shoe Stores. So here is the data that is given to us, the annual demand. So they have given us data like, they need 500 shoes every quarter, and we have 4 quarters. So we can get the annual demand, which will be equal to our quarterly demand times number of quarters in a year. So that's going to be like 500 times 4 quarters, and that's going to give you that many shoes per year. So that's our annual demand here. Currently, they're using order quantity of 500 shoes per order. That means if they're placing an order, they're placing an order of 500 shoes at a time. Ordering cost is $30 per order, which means if you place an order, it will cost you $30. Unit cost currently they're paying is $28 per pair of shoes. This is the purchasing cost. This is how much they are paying for each pair of the shoes. And then you have annual holding rate, which is 20% of the unit cost. This is how much you're gonna pay per year to hold on to the inventory, like one pair of shoes. So if you want to hold on to one pair of shoes for a year, it's going to cost you here, let's say equals to 0.2 for 20% times, this is what you're paying right now. So you will be expending $5.60 to hold on to one pair of shoes that you bought for $28 for 1 year in your warehouse. So that's annual holding cost here. So we have to answer a lot of questions here. Now, one thing you need to understand that the inventory discount model works on the principle of discounting, which means the more you're gonna buy, the less you're gonna pay. For example, if you buy less than equal to 99 pairs of shoes, per pair of shoes you're gonna pay $36. But if you buy anywhere between 100 to 199, that unit cost will go down to $32. And if you buy more than that quantity, let's say 200 and between 200 and 299, unit cost is gonna go down further to $30. And if you buy more than 300, the unit cost will go down to $28. So as you know, right now they are buying 500 shoes every order, and that's more than 300, and that's why they're paying $28 right now. Okay, so what you need to do here is, the question is, are you going for optimum order quantity, like whatever you're paying right now, is that the optimal level, or can you bring it down the annual inventory management cost? So that's the thing we need to order. That's the thing we need to figure it out. So the first thing we had to do here is find annual inventory management cost for the current order size of 500 units. So that's going to be given by this formula here. Q is the order size divided by 2 times CH is the annual holding cost plus annual demand divided by current order size, which is Q, times ordering cost, plus we're going to add the purchasing cost as well. So purchasing cost is going to be annual demand times C, which is the unit cost. So far we have ignored the purchasing cost solving all the problems because it was not affecting our decision as such when it comes to comparing different order sizes. But here purchasing cost gonna play a role because the unit cost decreases as you order more or in bigger order sizes. So that's why we're going to consider purchasing cost here as well. So the total cost or total annual inventory management cost will be given by equal to order size is 500 divided by 2 times ordering cost. In this case is going to be this much, $5.60, plus my ordering cost is going to be 2000 shoes per year divided by ordering cost is $1.30 times, I'm sorry, it's going to be H5 divided by Q, which is 500 units times ordering cost, which is $30. And then I have to add my annual purchasing cost, which is annual demand 2000 times unit cost, which is this much. So this times, let's say this much. Okay, so that's gonna give me $57,520 per year. So this is how much you are spending per year to manage the inventory. Okay, that includes your holding cost, your ordering cost, and your purchasing cost. Okay, so now the question is, can you lower it down? Can you lower it down further? Because you know the range of the order sizes and unit prices. So as you increase the order sizes, the unit prices goes down. Uh, and that might have an impact on your total inventory management costs. So whatever you're paying right now, is it the optimal optimal amount, or can it be lower? Let's go ahead and figure it out. So what we're gonna do here, we're gonna populate a table here. Okay, now this formula, you're all aware of it. Order quantity is given by this formula, Q equals square root of 2 times annual demand times ordering cost divided by holding cost or carrying cost. So that's the same thing. Okay, so annual holding cost is given by your order quantity, Q divided by 2 times your holding cost. Annual ordering cost is given by annual demand divided by your order quantity times ordering cost, and your annual purchasing cost simply equals to annual demand times uh, purchasing cost per unit. So that's gonna be purchasing cost sometimes versus C. Okay, C is a unit cost. So here given unit cost C to $28. Okay, so let's see what we're gonna do is, this is what is given to us. Based on this one, we need to find the optimal order range that's gonna lower our annual inventory management costs. So first thing first, what we need to do for every order range, we have given the price per unit, we need to find order quantity. So that's going to be given by order quantity formula is this much, this here given, right? So Q equals square root of 2 DC over CH. So that should be SQ square root of 2 times D is 2000 times ordering cost, which is 30, and I'm gonna fix this thing. I can fix this one, so because they're not gonna change. Okay, uh, divide by my unit cost, which is this much. This is the ordering cost, I'm sorry, the carrying cost, which should be equals to 20% of the purchase price. So what we're gonna do here is we're gonna say 0.2 times B47. Okay, so I'm gonna take the whole square root of that one. So I'm gonna put this in parentheses as well. I like putting my numbers in parentheses to avoid any sort of confusion. Okay, so that's gonna give me 129.1 units. So this is basically telling me that if you order anywhere between 0 to 99, or if you're paying $36 per unit, your order quantity is going to be 129. Now the rule is, if this order quantity 129, if this goes outside the range, allowable range, which it is right now, because allowable range is 0 to 99, and 129 is more than that range. So this will never produce optimal um, cost. That's the rule. If this goes outside the range, if the order quantity goes outside the order range, that particular order size will never produce optimal inventory cost. So we're gonna go to the next one. So that's what I have mentioned here. Since 129, I would say just gonna be more precise, 0.1 is greater than the range of 0 to 99, this order quantity cannot yield an optimal solution. So we're going to go to the next range here. Now this already calculated it, my formula is all there. All I need to do is, I need to just drag it down. So it's going to calculate for all of them. Okay. So I'm just going to make sure I retain my formatting. Okay, so let's see here. 136.93, is it between 100 and 189? Yes, it falls within the range of 100 and 199. So this gonna might produce an optimal solution. So here I need to find annual holding cost, which is given by this formula here, Q over 2 by times carrying cost. So it's gonna be Q is this one. Okay, I'm gonna Q divided by 2 times, I'm gonna say 20% of the carrying cost, which is 32. Okay, so that's going to give you $438.18. Okay, because you remember here CH. Okay, CH is going to be calculated as 20% of the unit cost. Okay, 20, because that's given here, right? The annual holding rate is 20%, and our unit cost in this case is 32. That's why I did this one here. So if you see function F2 here, 20% of B48, that gives me inventory carrying cost for this particular order size here. Okay, something to keep in mind. So here annual ordering cost is going to be given by annual demand. So I'm going to find my annual demand here. I'm going to press F4, annual demand divided by order quantity, which is this much here, times ordering cost, which is $30. I'm going to fix this one as well. Okay, so that's going to give me annual ordering cost. So as you know that at the optimal level, annual holding cost and annual ordering cost will almost equal. So in this case, they are perfectly matching. Okay, something to keep in mind here. So annual purchasing cost here is the annual demand, which is 2000 units. I'm going to press function F4. I'm going to fix that one. Times carrying cost is $32 here. Okay, that's going to be $64,000 per year. So total cost per year is going to be the summation of annual holding cost, annual ordering cost, and annual purchasing cost here. So that should equals to sum of these three numbers here. Okay, so if you order anywhere between 100 to 189, your order quantity should be 136.9, almost 137 units. That's what you must be placing an order for, and your unit price will be 32, and your total inventory management cost will be 64,876. Your current is lesser than that, 57,000. So this is not a optimal solution, because currently you're paying lower than that. So let's go to the next one. So the next range is 200 to 29. So I calculated here the ordering cost, which is 141. Now the rule is, if this ordering quantity, not the ordering cost, the ordering quantity, if this ordering quantity is less than the given range, then you update Q to the minimum value of that range. So here, since 141.42 is less than 200, that is the minimum value of the range, we're gonna set Q equals to the minimum value of that range, which is 200 units. Okay, so this Q becomes 200 units here because the calculated Q is less than the minimum value of the range. So if calculate Q is more than the maximum value of the range, you go to the next one. That's what we did here. But if it is less than the minimum value of the range, then you update the Q to the minimum value of that range. That's the rule. That's going to give, because otherwise it may not work. It may not give you the optimal solution. Now I have already, the beauty about the Excel is, you can just drag these formulas down because you already put in the necessary condition. So I'm just going to drag it down here for all of them, and I'm going to make sure that I retain my those things there. Okay, now here we cannot use what we call C49. Okay, C49. So let me do it again just to avoid the confusion. I'm just gonna do one at a time. So I'm gonna drag this one. I'm gonna change this C49 because C49 not gonna work. We updated it to 200, right? So I'm gonna say here, just use, I'm gonna replace that with a constant of 200, right? Likewise, I'm gonna do it here. Not the C49, but we're gonna do 200, and so here. So this is right. No, it's not going to change. H5 is annual demand. B49 is the unit price we're going to pay. So these are all going to work. So this is going to work as well. Okay, so I'm going to highlight this one. So if you set your order quantity to 200 units, your total annual inventory cost going to be 60,900, which is less than the last solution. Okay, so last one was 64,876. So we are going down, we are doing better, but still currently we are paying less than that amount. So right now we are paying only 57,520, and this is more than that. So there is no point going for this order quantity either. So let's go to the next one here. Next one, we again calculated the order quantity, and this order quantity was less than the minimum value of the range, which is 300. So we're gonna set Q to 300 here, and we're gonna calculate all of them. This time I can simply copy this one here, and I'll change 200 to 300. Okay, so let's say I'm gonna retain my format here. Okay, let's not do that. So let's take this format. I don't want to lose my dollar symbols. Okay, let's see. Okay, just to be on the same side here. Okay, so here instead of 200, I know my order quantity is 300. Here my order quantity is 300 instead of 200, and this is not going to change because B50 is $28. This is what you're paying right now. So in other words, if you place the order of 300 units, okay, your total inventory management cost, which includes holding cost, ordering cost, and purchasing cost, will equals to $57,040. Okay, $50,040, which is less than 57,520, right? So it's going down. So this is the lowest cost so far we have obtained. Okay, so I'm going to say that so the lowest annual total inventory cost of 57,040, right, 0.00, I'm going to say dollars. Okay, occurs for Q equals 300 units. So if you place 300 units, your inventory total annual inventory cost will be $57,040, which is lowest. And if you reduce the existing order size of 500 units to 300 units, the total savings is going to be, we're going to calculate this one, which is going to be, so right now, that's this much you're spending, and now it's going to be this much. So the total saving is going to be $480 per year. So it's like win-win situation. Right now you're ordering 500 pairs of shoes, and your inventory management cost is higher. But now you can lower it to 300 units, which means you're going to save the space as well in your warehouse by ordering less. And by doing that, you are also lowering your inventory management costs. Something you have to keep in mind. So even as order size of Q equals 300 units, uh, shoes will still be purchased at the lowest price of $28, right? That's what we are paying right now. That's what you paid earlier when you're ordering 500 pairs. So going forward, I would rather use Q equals 300 units again, because it's going to help me save the space of 200 pairs of shoes, which I don't need to store anymore. And while doing so, I will also lower my total inventory management cost by almost $500 per year. So this is how I would interpret this solution here. Now just keep in mind, these are the rules. If the range is above the maximum value of the order range, the order quantity is above the maximum value of the order range, you go to the next one. If it is lower, if the order quantity is lower than the minimum value of the order range, then you update the Q equals to that minimum value. These are the rules, and this could be proved. If you read the book, you'll understand that thing. And this is how you would solve this problem here. With this, I'm going to end my video. Thank you very much for listening.